Hi everyone, welcome to Cola Teaches Math. So today we're going to review Unit 3, what you need to know in order to succeed on Unit 3 on the AP. So Unit 3 is derivatives, most importantly chain rule, implicit, and inverse. Okay, so I'm going to go through all of these with you right now. Alrighty, chain rule. So for chain rule, I always say the following in my class. So when I'm taking the derivative of this, okay, so f prime of x, we're going to bring down the power, keep the inside, subtract 1 from the power, multiply by the derivative of the inside. Do not forget to multiply by the derivative of the inside, and that is it. Okay, next one, chain rule with trig. And I'm going to write down what I always say. I always say bring down power, keep the inside, subtract 1 from the power, multiply by the derivative of the inside. Okay? Now, when I'm doing chain rule with trig, I say something different. I tell my kids, derive the trig, keep the angle, derive the angle. So I'm going to write that out. Derive the trig, keep the angle, derive the angle. Done. You can write that as -5 sine 5x. Okie dokie, next one. We know that this is the same thing as x to the 4th minus 3 to the 1/2 power. So what we're going to do is we're going to bring down the power, keep the inside, subtract 1 from the power, multiply by the derivative of the inside, and we're going to chat about how to rewrite this. So anything that I'm highlighting in green needs to drop and stay in the denominator. So we're going to have 4x cubed on top over 2 rad x to the 4th minus 3. You're going to then simplify and divide the 4 over 2, and you're going to get 2x cubed over rad x to the 4th minus 3. Dunzo. All right, let's do a fun chain rule with trig. Bring down the power, keep the inside, subtract 1 from the power, multiply by the derivative of the inside. So I'll multiply by the derivative of the inside, and I will write the derivative in black. Derive the trig, keep the angle, derive the angle. Now, how are they going to simplify that? By doing the 2 times the 4, and they're going to write my answer as 8 sine 2x cubed cosine 2x in any order they want. Done. All right, next one. If there is a number in front of the trig, it's going to just pop on down into my derivative. If you don't believe me, try the product rule. It always works. So we're going to derive the trig, keep the angle, derive the angle, and that's going to be 20 secant squared 4x. Done. And last but not least, before we move on, bring down the power, keep the inside, subtract 1 from the power, multiply by the derivative of the inside. Okay? So that's how you're going to attack chain rule. Okay, the next one we're going to chat about is finding the derivative of an inverse function. So let's talk about the rule first. So if g, is the inverse of f, and they want us to find g prime of a, it's 1 over f prime g of a. Okay, so that's going to be our formula that we're going to use. So let's look at this example here. The table gives values of the differentiable functions f, g, and f prime at selected values of x. Let g equal to the inverse of f, and they want the value of g prime of 1. So first thing I like to do is plug into my formula. G prime of 1 is 1 over f prime g of a. And we need to work our way from the inside out. So we need to find, that should say g of 1. Silly. So first thing we need to do is work our way from the inside out. we need to figure out what g of 1 is. Now here's the issue. They don't give me any information about g in the table, but we can use my trick here. And my trick is f of what equals 1. So g of 1 equals that. Because when you have inverses, the domain of the function becomes the range of the inverse, and the range of the function is the domain of the inverse. So now we're going to look at my table and say, okay, f of what equals 1? Well, look, f of 4 equals 1. So I'm going to replace g of 1 with 4. So now we're going to have, I'm going to write it over here, g prime of 1 is 1 over f prime of 4. Okay, what is f prime of 4? We'll go to the table. F prime of 4 is 6. So this is going to be equal to 1/6. Done. Now what if it's not a table? Here we go. If f of x is 3x squared plus 1, g is the inverse of f. They want the value of g prime of 13. So first step, set up the formula. G prime of 13 is 1 over f prime g of 13. Set up my trick. F of what equals 13? So g of 13 equals that. Now, a lot of the times you can kind of just look at it and say, oh, it's this. So if we do that, we can see, you can, listen, if you can't do it in your head, then you can actually literally set 3x squared plus 1 equal to 13 and solve. But you can also just say, oh, x has to be 2. So this is going to be 2 here. So now I'm going to replace g of 13 with 2. So we're going to have 1 over f prime of 2. Let's take the derivative. I'll do it in blue. F prime of x is 6x. And now f prime of 2 is 6 times 2, which is 12. So this answer is going to be 1/12. All right, next. Inverse trig. You have to memorize these rules. The derivative of an arc sine is 1 over the square root of 1 minus u squared du. Derivative of u. I like to write it as u prime. So u prime, not u to the first, u prime. Arc cosine is negative 1 over 1 minus u squared times u prime. Some teachers put the u prime on top. It's the same thing. Arc tan is 1 over 1 plus u squared times u prime. Arc cotan is the negative of it. And these last two are very, very, very rarely on the AP. And it's negative 1 over the absolute value of u, square root u squared minus 1 times u prime. And then arc secant is the same thing without the negative. So now we're going to go over here and we're going to use these rules to derive the following. Do not forget to derive the u. So first thing, this is my u. It's going to be 1 over the square root of 1 minus u squared du, 2x. Done. Arc tan, 1 over 1 plus u squared times the derivative of 5x, which is going to be 5. Done. How could the multiple choice write it, guys? They can do 5 over 1 plus 25x squared. And for this one, they could write it as 2x over the square root of 1 minus x to the 4th. So just be aware of that. All right, this one, y prime, 1 over the square root of 1 minus u squared du. I said memorize rad x derives to 1 over 2 rad x. Here's a perfect example, because let's simplify this practice. This rate that I circled in green, it's going to become 1 over the square root. Rad x squared is just x. The radical drops out. Times 1 over 2 rad x. So how could they write this? I don't know. They'd probably leave it like that or something like that. We're going to stop there. And last but not least, we're going to do a lovely little product rule here. uv. So the derivative is going to be u v prime. Okay, how do we derive cos? It's negative 1 over square root of 1 minus u squared times du, the derivative of u, plus v, u prime is 1. Dunzo. Okay. All right, next. Last but not least, I love a good implicit question. This one's really good to go over. So if they want us to find dy dx, well, first of all, you use it when you have x and y on the same side of the equal sign. Okay? Same side of equal sign. So I'm going to group it like this, and we're going to product rule this. So dy dx, to find the derivative, it's going to be u v prime. So you're going to derive the y like normal. So y is v, so that's going to be 1 dy dx. Anytime you derive the y, you better throw a dy dx on. Plus v, u prime, you derive the x's like normal. We do not need to add anything on because we're deriving with respect to x. Equals the derivative of 2 drops out at 0. And the derivative of y cubed is 3y squared. Derive it like normal. Throw on a dy dx. Now you're going to move all the dy dx's to one side. Now that we have this, if we get dy dx by itself, so dy dx is going to be, well, look. So this is what you're going to do. You're going to rearrange it. You're going to do 6x dy dx minus 3y squared dy dx equals negative 6y. You're going to factor out the dy dx, which gives you 6x minus 3y squared. And then you're going to divide by the parentheses to get negative 6y over 6x minus 3y squared. And you could reduce that if you want to by dividing everything. All right, so now vertical tangent. So vertical tangent is when dy dx is undefined. So I'm going to take the denominator and set it equal to 0. You want to solve for the variable that's easiest, and I would suggest to not worry. You don't want to have to deal with square roots. So if I do that, I'm going to get 6x equals 3y squared. Divide by 6. X is y squared over 2. We're now going to take this and plug it back into the original everywhere I see a y. So we're going to have 6x y squared over 2. I'm sorry. Okay. We're going to take this and plug it back in everywhere we see an x. So I'm going to get 6x y equals 2 plus y cubed. So if you simplify this, you get 3y cubed equals 2 plus y cubed. 2y cubed equals 2. Y cubed equals 1. The cube root of y, cube root both sides, you get y equals 1. And if y is equal to 1, we can take that, plug it back in here, and we're going to get x is equal to 1/2. Done. Let's do this process now to find the equation, the coordinates of the horizontal tangent. All right, so a horizontal tangent is when the derivative is equal to 0. So dy dx is equal to 0. So we have my derivative up here. Let's set the top equal to 0. Because when you're setting dy dx equals 0, you're just setting the numerator equals 0. All right, this one's really nice because we're able to just solve for y. And then if you follow my steps from before, we need to take y equals 0 and plug it back into the original. So when I do that, we're going to get 6x times 0 equals 2 plus 0 cubed. 0 equals 2 plus 0, 0 equals 2. Not true. So that means no horizontal tangents. Okay, done. And that is Unit 3, nice and quick.